Okay, today we'll see about lens. So lens. So what is a lens? In order to understand lens, you need to understand that it's also spherical. Okay, it is spherical. Okay, and the difference between the lens and the mirror is lens is transparent, right? If you take the case of lens, okay, lens, it is a transparent medium. That means through it the light can pass. So a transparent medium, right? Lens is an optically transparent medium. When I say optically transparent medium, it means that light can pass through it. Better understanding of lens will be a transparent material bounded by two surfaces of which one or both surfaces are spherical forms a lens, right? Once again, let me repeat that. A transparent medium, right? A transparent medium bounded by two surfaces of which one or both surfaces are spherical. So if I take this, okay, if I take this, right, so I can say that we have two surfaces and both these surfaces are what? And both these surfaces are spherical, okay, and also they are transparent. Transparent bounded by two surfaces. You have surface 1 over here and you have surface 2 over here, right? Bounded by two surfaces, and both these surfaces can be spherical. When I say can be spherical, and also it can be plane. Let's say, for example, if I take another example of a lens, you have this one lens and then this, okay, it is also a lens here. This surface is spherical whereas this surface is plane, right? So when it comes to lenses, in our section we'll be discussing about two types of lenses, though there are many, right? So we'll be discussing about convex lens and concave lens, right? So convex lens, right? So when you look at this is a convex lens, right? You have two surfaces, surface 1 and surface 2, and both these surfaces are what? Both these surfaces are spherical, okay? Now we will also, this is called as what? This is called as a convex lens, okay? This is called as a convex lens. Then we have another one, okay? We have another one over here. You have this. This is a concave lens. Now in this case over here also surface 1 is spherical and surface 2 also is what? Spherical. So this is a convex lens, and this is a concave lens. But do you think there are only these two types of lenses? Sorry, we have more than this, right? We have convex lens, we have concavo convex, right? When I say concavo convex, that means what? One surface is, let's say something like this, okay, where one surface is convex and the other surface is concave, so it will be called as a concavo convex, right? We have plano convex. This is plano convex, where one side is convex and the other one is plane. So we have varieties of lenses, but for our study here in your section of lenses, we will discuss only about two types of lenses. And what are those two types of lens? One is convex lens and the other one is a concave lens. So now when we start off, we will start off with what? With a convex lens, right? It's a transparent medium bounded by two spherical surfaces, right? When I say transparent medium bounded by two spherical surfaces, it means what? It means that the light can pass through it, okay? This is a convex lens. Now in case of convex lens, if you take the case of mirror, for just taking you back, if you take the case of mirror, the central point was called as what? The central point was called as the pole, okay? If you remember, it was called as the pole. Whereas if you take the case of lens, the central point is called as what? The central point is called as a optical center, okay? Please keep that in mind, optical center, okay? Now in case of lens, right, in case of lens, you will find that all the rays of light, okay, all the rays of light traveling parallel to the lens, right, when they are traveling parallel to the lens, you know what is going to happen? These rays of light, in case of a convex lens, all these rays of light after refraction, right? After refraction, you will find that all these rays of light will tend to meet at a single all these rays of light will tend to meet at a single point. Okay, will tend to meet at a single point. So you find then a very interesting thing here, that in case of convex lens, all the rays of light after refraction meets at a point, right? Since all the rays of light after refraction are meeting at a point, this convex lens is also called as what? Is also called as a converging lens, right? It is also called as a converging lens. Okay. Now, when we take the case of the other one, concave lens, okay, if you take the case of concave lens, you will find that you will find something different happening in case of concave lens. If I take the case of a concave lens here, right, if I take the case of a concave lens, you find, let's say this is the optical center, this line traveling straight is called as the principal axis, right? The rays of light traveling parallel to the principal axis in case of concave lens, right? In case of concave lens, all these rays of light traveling parallel, they will what? They will refract. They tend to reflect in another direction, and it appears what? It appears that all these rays of light appears to refract from a single point here. It appears to they appear to refract from a single point. You know, they are diverging in different directions, right? They are diverging in different directions. Therefore, concave lens, right? Concave lens is also called as what? Concave lens is also called as a concave lens is also called as diverging lens, right? So we have seen that, we have seen just two or three simple things. What is a lens? A lens is a transparent material bounded by two surfaces, of which one or both surfaces are spherical. Okay, then we have in our course here in class 10, in lens we will be discussing about two different types of lens. One is called as the convex lens and the other one is called as the concave lens, right? Okay, the next topic that we are going to see will be image formation by lens using ray diagram. Okay, using ray diagram. Now, in order to understand this, once again we will like to go back, right? We will like, before we go into the lens, the image formation by a lens, let's go back to the image formation by a mirror, right? If you take the case of, let's revise, okay, let's revise the mirror. In case of mirror, if you remember, there are three important rays. If I take the case of a mirror here, right, you know that this is going to be the principal axis, this is going to be the focus and the center of curvature. A ray of light traveling parallel to the principal axis after refraction passes through the focus, right? A ray of light which passes through the focus after reflection will become parallel to the principal axis, right? This is ray 1, that is a ray of light which travels parallel to the principal axis after reflection passes through the focus. A ray of light which passes through the focus becomes parallel to the principal axis. And the other one, a ray of light which passes through the center of curvature travels straight, taking the same path back. So these were the three rays of light or three rules that we have seen in case of mirror for finding the images or the image formed by a mirror. Similarly, in case of lenses also we'll follow more or less the same way. Okay, so in case of lens also we will try to draw the ray diagram. The very important thing you need to keep in mind that over here in case of lens there are two principal focus, right? See, if you take y2 principal focus, if you take the rays of light traveling from this side after refraction, they will meet here. All the rays of light after refraction, they will meet here. So you find that there is one focus here. If you take the other side, if the ray of light comes from this side, you find that after refraction they will meet here. So that is why in case of lenses we have two principal focus. Okay, please keep that in mind, f1 over here and f2 over here, right? So let's look at rule number 1, right? When you look at rule number 1, what is rule number 1? A ray of light, okay, a ray of light which is traveling parallel to the principal axis, right? A ray of light that travels parallel to the principal axis after refraction will pass through the focus, right? Same like mirror. A ray of light which travels parallel to the principal axis after refraction will pass through the focus. Okay, then so this is your ray 1. Please keep that in mind. Ray 1 or rule 1. A ray of light traveling parallel to the principal axis after refraction passes through the focus. Then you have 2. What is 2? A ray of light. Okay, a ray of light which passes through the focus, right, becomes what? Becomes parallel to the principal axis. You can see here a ray of light which passes through the focus, right, which passes through the focus becomes parallel to what? Becomes parallel to the principal axis. So keep this in mind. This is rule 2. Okay, then third one is a ray of light. Okay, a ray of light which passes through the optical center. This is O. So a ray of light which passes through the optical center will take the straight path and follow the same path back, right? So this is 3. So if you recollect the mirror, in case of mirror also what it was, a ray of light which travels parallel to the principal axis. In case of mirror, it was after reflection passes through the focus. But in case of lens, a ray of light which travels parallel to the principal axis after refraction will pass through the focus. A ray of light that passes through the focus, okay, will become parallel to the principal axis. This is the principal axis and becomes parallel. Then 3, a ray of light which passes through the optical center follows the same path back. So these are the 3 simple rules that you need to keep in mind when you are to find the position of an image. Okay, position of an image in case of lenses, right? Now let's try drawing or finding out the position of the images. Okay, on the screen what you will see is we have a convex lens, and then we have focus 1, focus 2, twice focus 1. Sorry, this should be focus 1 and this should be focus 2. Okay, it is same like mirror, right? In case of mirror we write f and c, twice the focal length. So in case of mirror we would be writing c, but in case of lens we are writing 2f1. Over here in case of lens we are writing 2f2, right? So what happens if an object is placed, okay, if an object is placed, let's say if an object is placed, let's say over here AB, what happens if an object is placed behind 2 twice f1, or let's say in another way, if it is placed behind the center of curvature, right? Yeah, you can see here the object is placed behind 2f1. So follow the rule. Rule 1. What does rule 1 say? Rule 1 says that a ray of light, okay, a ray of light which travels parallel to the principal axis, right? A ray of light which travels parallel to the principal axis after refraction passes through the focus. No problem, simple as that, right? A ray of light which travels parallel to the principal axis after refraction passes through the focus, right? Rule 2. You can take any one out of the 2 remaining. So I can take this one. See, I can take you have an option of taking a ray of light passing through the optical center, directly optical center, right? You can take, let's say if I take this ray of light which passes through the optical center, follows the same paths without any refraction, right? So both these rays of light are meeting here, so it is at this point, right? It is at this point, clear? So I write here B dash A dash. So it is at this point that the image is formed. So if an object is kept behind C, right, or behind 2f1, the image is formed between f2 and twice f2, right? Okay, so now what will be the nature, right? What will be the nature of the image formed? That is also another very important thing. So you'll find that, right, you'll find that the image formed is diminished, right? If the object is kept behind 2f1, the image is formed between f2 and 2f2, and this is diminished. What do you mean by diminished? Diminished over here means the image formed is smaller than the object. Okay, the image formed is smaller than the object, and since it is below the principal axis, Since it is below the principal axis, so it will be what? It will be real and inverted, right? Below the principal axis, real and inverted. So this is case 1. So if the object is kept in case of convex lens, if the object is placed beyond 2f1 or twice f1 or beyond center of curvature, whichever you feel comfortable to understand, the image is formed between f2 and 2f2. The image size of the image is smaller, the size of the image is smaller than the object, okay, smaller than the object, and also it is what? And also it is real and inverted, right? This is 1. The next position is what happens when the object is placed at 2f1, right? 2f1, this should be 1, I'm always making a mistake. 2f1, when the object is placed at 2f1. Now what does 2f1 means? Just try to recollect with me. 2f1 means it is at C, okay? So if the object is placed at C, then in case of mirror, the image was also formed where? The image was also formed at C. We are only changing the nomenclature here. Instead of using C, we are using 2f1 and 2f2, right? Now in mirror, if you recollect in mirror, if the object is kept at C, that is 2f1 here, the image is also formed at C, that is 2f2 here, right? So let's try that. So I'm keeping an object, right? I'm keeping an object at 2f1, right? I'm keeping an object at 2f1. So the rule says a ray of light which travels parallel to the principal axis will pass through what? Will pass through the focus. So this is the point through which the ray of light is passing. Then second ray of light you can take, it will what will happen? It will pass through the optical center. Now you find that this is the place where the rays of light are meeting, and therefore the image will be formed where? The image is also formed here, right? The image is also formed here. So if you keep an object at 2f1, right, which is more or less like C in case of mirror, right, the image is also formed at 2f2, which is like C in case of mirror, right? Keep in mind only the name is changed, f2 f1, but the process remains the same. Now you'll find that of course this is also below the principal axis, okay? This is also below the principal axis, and since it is below the principal axis, it is going to be what? It is going to be real and inverted, okay? Real and inverted image. I am sure you will remember that if an object was kept at C, the image was also formed at C, and the size of the object image was same as the size of the object. So over here it is of what? It is of same size, right? The image formed is of the same size as the object, right? More or less you will find that the rules remain the same in case of locating the image formed by a mirror or lens. The rules remain the same, okay? Great. Now we move on to the next position, right? We move on to the next position, and that position is what? Coming ahead. If we keep an object between f1 and 2f1, right? f1 and 2f1, what happens? Let us have a look. So simple, a ray of light travels parallel to the principal axis, and after refraction it will pass through what? It will pass through the focus, right? Then a ray of light which passes through the optical center, right? Passes through the optical center. Now you see these rays of light are meeting here, right? These rays of light are meeting here. So you can very well see and find out that if the object is kept between 2f1 and f1, the image is formed behind 2f2. It is formed behind 2f2, right? It is formed behind 2f2, and you can look at the size, right? This is the size of the object and this is the size of the image. Since it is below the principal axis, definitely it is going to be what? Definitely it is going to be real and inverted, right? And another very important thing, it is enlarged. The size of the image is what? Highly enlarged, okay? Great. We move on to the next position. What happens if the object is kept at f1, right? If the object is kept at f1, no problem, follow the same rule. A ray of light travels parallel to the principal axis, and after refraction passes through the focus, right? Then another one is the ray of light will pass through the optical center. Now you find that both these rays of light, they are not meeting anywhere, right? You can extend it infinitely. They are not going to meet anywhere. They will remain parallel to each other. And since these rays of light are parallel to each other, what we can say? We can say that the image will be, of course, real and inverted. But what will be the position? The image is formed where? The image is formed at infinity. Okay, great. Coming to the next position. Okay, coming to the next position, that is, what will happen if the object is kept at f, if the object is kept between the optical center and f1, right? So I'm keeping the object here, right? I'm keeping the object here between the optical center and f1. So a ray of light travels parallel, right? And after refraction passes through the focus. This is not an issue, right? Now there will be a second ray of light. Okay, there will be a second ray of light which will pass through the optical center, right? Passing through the optical center. Now these two rays of light are not parallel. So unlike the previous one, in the previous case those two rays of light were parallel and so they were meeting at infinity. Now these two rays of light are not parallel. Okay, therefore what are you going to do? From this point you will extend, right? From this point you extend, right? You will extend, and when you extend you will find what? You will find that these rays of light will be meeting where? Will be meeting, it means the image will be formed where? The image is formed behind, right? The image is formed behind 2f1. It is a highly enlarged, right? It is highly enlarged image. So and also it is this is highly enlarged, right? Highly enlarged. And since it is above the principal axis, it is going to be what? It is going to be virtual and erect. Okay, above the principal axis, so virtual and erect. That's it. Great. In case of concave mirror, there is only one image formation. Okay, there is only one. No matter wherever you keep the object, the image will always be formed between what? The image will always be formed between f1 and the optical center. For example, if this ray of light, okay, in this case the ray of light travels parallel to the principal axis, right? And travels parallel to the principal axis, and after refraction it goes in this direction, right? Then you have another ray of light, okay, another ray of light passing through what? Passing through the optical center. So what you need to do is you need to extend, okay, you need to extend this ray of light which appears to be emerging from the focus. So you find that these two rays of light meet here. So no matter wherever you keep the object, in case of concave mirror, the image will always be formed between what? The image will always be formed between f1 and the optical center, right? So this is all about, okay, this is all about the image formation by what? Image formation by a lens, or by the two lenses here in your case, that is convex lens and concave lens.